So now that I've given you an overview of the structure and functionality of the Primality microservice, let's go ahead and take a look at its implementation. And so again, keep in mind that this is going to focus on the way this code uses the Java executor's new virtual thread per task executor model. And as usual, you can find this code in my GitHub repository, in the EX3 project, in the WebMVC folder, in my Live Lessons GitHub repository. So here we are in my Live Lessons GitHub repository for case study EX3, and we click down here into the server side, and you can see we're going to take a look now at the Primality microservice implementation. The main part of the code looks very familiar. We have a Primality application, which is the entry point into this particular microservice. Not a whole lot different from what we've seen before here, with one little exception perhaps. We used through an annotation a way of expressing to Spring that it can find the properties for this microservice over here in the resources folder. And if you go down here and we take a look, we'll see that there's a file here called Primality Microservice Properties. And if we click on that file, we'll see what the properties are. It gives a name and it gives a port number. So it's going to listen at port 8082. And we do it this way so we don't have to hard code any of that information into the code itself. We can put that in a configurations file and then be able to access or modify it through some other means without having to change the code itself. So just a nice way of kind of one extra level of indirection for the setup of this. Let's go ahead and take a look at the Primality controller. So this is just a good old controller, auto-wired with the service. All of its basic logic really comes from indicating how to map incoming paths that have the route name check primality list, which of course we define over here in the constants file. You can see that that's just defined as a constant. No real surprise there. And it just forwards down to the service. So let's take a look at the service because that does something a little bit more interesting. So here is the implementation of the service. As usual, we annotate it with a service, so we know it's going to be auto-scanned automatically by Spring to do the dependency injection and auto-wiring. Here's the main entry point method, check primalities, takes that list of integers that are prime candidates, and we define ourselves a local variable. I always get nervous when I write code like this nowadays because I don't like having variables just kind of sitting by themselves, but that's kind of the way you have to do structured concurrency because it's really kind of thinks it's kind of older school Java model often. And so what we're going to do in this particular case is go into a try with resources block that makes a new virtual thread per task executor, which we store in a scope field called executor. And then we say, hey, go ahead and pass that executor and the prime candidates to a helper method called getFutures. And let's take a look at getFutures. You probably already know what that's going to do. It's going to convert the list of integers into a stream. And then for each integer in the stream, it's going to check the primality of that integer. And it's going to do that by calling this little helper method. And what that's going to do, as you probably would have guessed, is it's going to use the executor. And it's going to submit a task. So it's submitting a callable. And of course, because we made a new virtual thread per task executor, each time we submit anything to it, it's going to create a virtual thread. It's going to go off and check to see if the number is prime. And it just does the brute force prime number check. We've looked at this before, so I won't go through it again. You can read the comments if you forget what it does. But we print the results out, so it'll be displayed through the logging window. And then we create ourselves a new prime result. And a prime result is just a good old Java record, which is a plain old data pod or plain old Java object. Shouldn't be called object, I guess. Plain old Java record. And basically, it doesn't store anything other than the fields, the prime candidate and the smallest factor that's returned from the isPrime method. No virtual pointer, no virtual table, no intrinsic lock, no intrinsic condition, just the plain old data. And you should also be aware that you can pass records back and forth through Spring. Spring knows how to serialize and deserialize records contents automatically, which is nice. So we make ourselves a new prime result, and that will then come back as a future to a prime result, because that's what we get back when we submit something. And so we're going to end up here, as you can see it, with a stream of futures to prime results, which we then turn into a list of futures to prime results, and that's what gets returned from the get futures method. And after this try block finishes, then we know that either something horrible has happened and there's been an exception, which there won't be in this case, or we know that all the computations are done, which is what will happen in this case. So as we talked about before, we then have to go ahead and take that list of futures to prime results and convert it into a list of prime results. And we do that with a little helper method that's sitting over here in the futures util class, because I like to reuse these generic methods. And what it does is it takes a list of futures to items of type T, generic items of type T, and then it turns that list into a stream of futures to type T. Then it uses the future result now method, which is relatively new with Java 20, and it converts it into a type T, an object, and then we turn that back into a list of objects of type T. So that's how we end up converting the results. And that's what gets returned back here from check primalities. So that's basically what we're doing here on the server side for the Primality microservice. Not a whole lot of extra stuff, but keep in mind how it does work when we compare and contrast it with the alternative approaches that use Java parallel streams.